For this video, we are going to cover relations and functions. The aims are define relations and functions, determine the domain and range in ordered pairs, identify if the relation is a function by ordered pair, mapping diagram, graphs, and equations. And you will have your task to check your understanding. At the end of this video, I would like to challenge you to check your understanding, so I prepared a task for you. Comment below your answers or questions about relations and function. You will see this task again at the end of this video. Let's define a relation. A relation between two variables x and y is a set of ordered pairs. An ordered pair consists of an x and y coordinate. Usually, it's in the form of the parentheses, wherein the first number is represented by the x and the second number represented by y. A relation may be viewed by ordered pairs, mapping design, graph, or equation, and I will give an example to each one of it. For the x values, it's also called as input, independent variable, and domain. For the y values, it's also called as an output, dependent variable, and range. Let's try this. Give the domain and range of the following relations. So we have here a relation in an ordered pairs, and it asks us to write or list down all the domain. So we have to put a bracket and list down all the first number in the ordered pair that represent the domain. So we have here -7, -3, -2, +4, and +6. So these are the domains of the relation. For the range, that will be the second number in the ordered pair, or the y values, and those are 1, 0, -1, 7, and 4. So that is our answer for the domain and range of the first relation. For the second relation, the domains are, once again, those are the first number of the ordered pair, and that will be -1, 0. Now, since the 0 is repeated, we don't have to repeat the 0 or 0 once more. We can just write only 1, 0. That represents for both of it. Then 6 and 7. So these are the domains. For the range, those are the second number, which is the -2, -3, 2, -2, and -7. So let's write it here. So once again, the range are -2, -3, +2, -2, and -7. So these are range and domain of the relation for our number 2. We have a question over here. Is a relation a function? So let's define what is a function. A function is a relation in which every domain has exactly one range. So we can only classify a relation as a function if and only if the domain has exactly one range. So let's apply that in this given ordered pairs. Here, which of the following relations are functions? Number 1, we have here a set of A. For us to identify if the relation is a function, we have to look over all the values of x. For example, letter A, we have 2, -1, 0, 3, and 5. Because with the value of x, it should be only used once and no other pair of range, so that we can classify it as a function. Now, since on letter A, there is no repeated x value, it means that this relation is a function. Letter B, let's look at the values of x. We have -6, -6, 0, 3, and 5. As you can see right here, the -6 repeated twice, so which means it has pair of 2 range, and it is not a function, okay? Because it has now 2 values of range. So it didn't follow the statement right over here. Number 3, we have letter C, set of ordered pairs. Let's look again for the values of x. So we have 2, 3, 5, -6, and +6. So there's no repeated values of your domain, so which means that every domain has exactly one range only. So letter C is a function. So that's how you're going to determine whether a relation is a function or not in terms of ordered pair. If the x values is not repeated, then it means it is a function. But if it is repeated, whether twice or thrice or more, then it is not a function. Here we have a set of mapping diagram, and it asks us to determine whether each mapping diagram is a function or not. Remember, a relation will be a function if the domain has exactly one range. So let's apply that here. For letter A, the first set, ABC, that will be your domain. Let us use D for domain and R for the range. And the R will be right here, which is for D, E, and F. Then let's check the domain. For letter A, it is paired up with D, and both B and C is paired up with E. So this is a function. It is a function because the domain is paired up exactly one range. And it doesn't matter even if A, B, and C is paired up with all by E. Still, domain has exactly one range. Letter B, so the first set will be the domain, and the second set will be your range. Let's check the domain. A is paired up with D and E. Letter B is paired up with F, and C don't have a range. So if you're going to look at letter A in your domain, it is paired up with D and E. So it has 2 range, then it is not a function. And as well as for the letter C, as you can see, it doesn't have pair of range. And to determine it's a function, that domain has exactly one range, but your domain of C don't have one. So it's not a function. Letter C, so let's name the first set as the domain, and the second set will be for the range. Let's check the domain. So A is paired up with R, B with no range, C with Q, D with S. Now, ABC is exactly paired up with Q or S respectively, but letter B don't have a range. So this is not a function. Okay, so each domain must have exactly one range. So that's why letter C is not. Letter D, again, the first set will be your domain and second set will be your range. Let's check the domain. So A is paired up with P and R. B is paired up with P and R as well. And both C and D is paired up with Q. As you can see, A and B is paired up with 2 range. So this is not a function. So that's how you're going to identify if the mapping diagram is a function or not. Next, function is as a graph in Cartesian plane. A graph of mathematical relation is said to be a function if any vertical line drawn passing through the graph touches the graph at exactly one point. Here, each graph represents a relation. Determine if the relation is a function. Number one, we have a blue line graph. So let's draw a vertical line. And each vertical line touches the graph exactly 1 point. So this is a function. So I'll use f as a function. Number two, so once again, let's draw a vertical line. And each vertical line cross the graph exactly 1 point. So number two is a function. Number three, we have a blue curve graph. So let's draw a vertical line. And each vertical line touches 2 points of the graph. So this is not a function. So let me use NAF for not a function. Number four, we have a circular graph. So let's draw a vertical line. And each vertical line touches the graph 2 points in 2 points. So this is not a function. So that's how we're going to determine if the relation is a function by graph. If the vertical line touches the graph once, then it is a function. If it touches twice, then it is not a function. Next, function as an equations. Each equation represents a relation. Determine if the relation is a function. Number one, x plus y is equal to 4. Remember, a relation will be a function if the domain has exactly one range. So to do that, let's isolate the variable y. So we have to do the inverse of x, which is minus x. And we have to do it both sides of the equation. So x minus x is 0. Bring down y equal 4 minus x. Now let's test this equation. If x is equal to 1, y will be 4 minus 1, and that is 3. And if x is equal to 2, y is equal to 4 minus 2 gives me the value of 2. So as you can see here, each value of the domain gives me exactly one range. So number one is a function. Number two is y squared minus x equal 9. So let's isolate the variable y. So the inverse of minus x is plus x for both sides. That will turn into y squared, and minus x plus x is 0 equal 9 plus x. Then we have to remove the square by square root both sides. So we can cancel out this. That will be y is equal to square root of 9 plus x. Now let's test this equation. Let's say x is equal to 7. So let's substitute it here. That will be square root of 9 plus 7 is equal to positive or negative square root of 16. And remember, if we're going to square root the 16, the possible answers are positive 4 and negative 4. Because positive 4 times positive 4 is 16, and negative 4 times negative 4 is positive 16. So if we have a domain of 7, our range will be positive 4 and negative 4. It has now two pair of range. So this is not a function. So that's how you're going to identify if the equation is a function or not. It's now time to check your understanding. Pause the video and comment below your answers or questions about relations and functions. And remember, math is more than a procedure. It's a powerful habit of thinking.